Hey everybody, in this video we'll talk about writing an equation that models variation. So in this type of problem, we are given what's called joint variation. And you can have, what joint variation is you can have combinations of inverse variations and direct variations within your joint variation. So if we go on to these problems, we're told that u varies directly with the square of p, and it varies inversely with d. So if we remember, inversely is y equals k over x, and directly is y equals kx. So we're going to continue to use k as our constant, but we're told that we're using u, and it's going to vary directly with the square of p. The square of p is just p squared, but then u also varies inversely with d, so we're going to have d on the bottom there. We can see our direct variation on the top, and we can see our inverse variation in this fraction that I circled in purple. So the top is k times p squared, which is a direct variation, and the fraction is k divided by d, which is an inverse variation. And we can combine them like this to make a joint variation. Okay, so the next problem says u varies jointly with p and inversely with w. So what we have is u equals k times p times d. That's our u varies jointly with p and d. And then u varies inversely with w, so we stick w on the bottom. So I can see my joint variation in k times p times d, and I can see my inverse variation in k over w. So my equation that I wanted to write is u equals kp d over w.